Welcome back. This is lesson 18.1 and in this lesson we'll learn about a special kind of software called a translator. So in this lesson we'll see what a translator is and look at three different ways of translating languages into machine code. Those are an assembler, an interpreter and a compiler. Machine code is the way that instructions are stored in binary form inside RAM. We hardly ever write programs in machine code. It's purely numerical. When we want to create software, the human programmer writes instructions using one of the many programming languages. But these instructions need to be converted into machine code before they can be used in the fetch execute cycle. Turning a program into machine code is called translation, and it's done by some software called a translator. There are three broad categories of translator: an assembler, a compiler and an interpreter, and they all do slightly different things. To understand this better, let's quickly review the difference between high and low-level languages. Low-level languages include machine code itself and assembly language. These are languages that very closely resemble the instruction codes used by the computer when it's operating. High-level languages are less similar to the underlying machine code, and they include interpreted languages and compiled languages. An assembler is used to convert a program written in a low-level language, specifically assembly language. Assembly language is very close to the instruction set. It consists of short codes, usually three-letter codes, that match the machine code numbers very closely. Different processors use different assembly languages. The job of an assembler is to take a program written in assembly language of one kind or another. It goes into the software called the assembler and is turned into numerical machine code, which is then stored in RAM. The machine code can then be run through the instruction cycle. In all low-level languages, there is a one-to-one or more or less one-to-one match between the instructions written in the language and the numbers of machine code. This gives you better control over the processor itself and the individual registers. The mnemonic or number codes of a low-level language are converted directly into binary signals, which are linked to a particular instruction set. Of course, there's a major disadvantage that programs are much harder to read, write and amend when they're written in this low-level language. And therefore it's extremely difficult to write long and complex programs. And when there's a difficult programming task to be done, in most cases programmers will choose a high-level language. It's worth noting that low-level languages were the first to be invented, and this is how scientists controlled the earliest computers. But nowadays, most work is done in a high-level language. When we're using a high-level language, we can use variable names instead of describing exactly which registers or memory locations to use. And our instructions don't need to match exactly to the machine code. One line of Python, for instance, could be converted into several lines of machine code. We lose that closeness to the hardware. We're not controlling the individual memory locations with the same close control that we have in a low-level language. And our program is not linked to a single instruction set. So if we write a Python program, we can then run it on many different sorts of computer and it will work on all of them. This wouldn't be the case with a low-level language. Of course, it's much easier to write, edit and read programs that are written in a high-level language, and it's easier to read and understand them. The invention of high-level programming languages is what really made the evolution of modern complex software possible. So a high-level language program must be converted into machine code, and there are two different types of software that will do this job for us: a compiler or an interpreter, and they work in slightly different ways. Most languages can be classified as either compiled or interpreted languages, and there's a list on the screen. Python, that I'm mainly using in these lessons, is an interpreted language, though you can get compiled versions of Python. But in general, languages fall into one category or the other. A compiler, and in this example I've got a little scrap of Haskell there. A compiler takes a complete program and produces a file in the computer's memory of machine code that matches the program that you've just written. So before you run the compiler, you've got one program. After you've run the compiler, you have two files in your computer's memory: the program that you started with and a matching file of machine code, typically an exe file. That is a file with the end .exe that you can run on your computer. Load it into RAM and run through the instruction cycle. So to recap, the input to a compiler is an entire program file, and an output is a new file of machine code instructions called an executable file or an exe file that you can just run on your computer. Can you think what are the advantages and disadvantages of producing a complete executable file compared to Python, which doesn't produce a second file of this kind? I'll have a little think about it. I'm going to talk about it on the next slide, so if you want to pause to write down your ideas, discuss it with anybody else, this would be a good point to hit pause. So here are some advantages and disadvantages. If you end up with an exe file of machine code, it can be run then by anybody. You can save it, you can copy it, you can share it, you can sell it. It's independent of the programming language that you used to create it. And therefore, if you are a professional programmer, this is almost certainly the option that you would want to go for. There are some disadvantages. The entire program has to be completely free of errors in order for you to compile and run it at all. And every time you make changes to it, that would create a new file of machine code. If you make edits to your program but you don't run the compiler, then your executable file and your program file won't match each other. So it can get quite complicated, particularly when you're learning programming, because you can have multiple versions and it can be hard to keep track. And finally, because the machine code is related to a particular processor's instruction set, that file will only work on your chosen type of processor. And therefore, if you are a programmer and you want to sell your software, you'd probably produce multiple versions based on the different instruction sets. An interpreter works in a completely different way. A single line of your Python program is sent to the interpreter at any one time. So in this case, total equals 0. The interpreter causes the control unit to send out control signals that match this line. So the control unit might tell the RAM to store a value equivalent to 0 in an address location identified by the name total. The interpreter then forgets that line that it's just carried out completely and goes on to the next line of the program. Nothing is saved in memory. So the interpreter reads through the code one command at a time, converts the command into a control signal which is immediately implemented by the processor. The interpreter then forgets the line that it's just interpreted and goes on to the next one, and no machine code is made or stored in RAM during this process. At the end of the interpreting process, you've still got the Python program that you started with and nothing else. Can you think what the advantages and disadvantages of that are compared to using a compiler that creates you an executable file? Once again, have a think about it. This would be a good time to pause the video. So there are many disadvantages to using an interpreter. You don't end up with a file, so you really don't have anything that you can sell or share. The only thing you can share is your source code. That is your original Python program, and you may not want to share that with people. Once you have shared it, you've kind of lost control of it. However, there are advantages as well. It's good for a learning language because immediately that you make a change to your program, that change is reflected in what the computer does. Furthermore, a Python program or any other interpreted program can be run on any computer because the interpreter will turn the program into commands that suit that computer. And I'd like to use the example of JavaScript. JavaScript is what gives most web pages their functionality. So a programmer will write a JavaScript program, put it into a web page, and then every computer that connects to that web page will be able to run that program. It doesn't matter what type of processor they've got. So this has been quite a complicated lesson. You should know what a translator is, and you should know a few facts about assemblers, interpreters and compilers. Let me say something very briefly that you can, this would be the bare nutshell of what you should remember. An assembler is a low-level language interpreter, and it matches machine code more or less one-to-one. An interpreter is what you're familiar with Python. It reads through the program, carries out each command, but doesn't save anything to RAM. And a compiler looks through the whole program, and instead of carrying out the commands, it turns them all into machine code and saves them as an executable file in memory. If you're one of my students, there's a worksheet on translators that you can download from the Moodle. We'll continue talking about the compilation process in the next lesson, so bye for now.